Greetings. Welcome to another edition of Math with Loki. On today's episode, we will explore the key features relating to graphs and equations of the sinusoidal functions.
Thanks for checking in. We're going to do last day test preps for sinusoidal functions. I think if you watch this 1 or 2 or 3 times, you're going to get a great benefit out of it before the test. So we're going to have questions where you're given a graph and you're going to have to pick a multiple choice response for an equation of that graph. And we want to be systematic about the way that we approach these. And I'm going to show one way of going about things. You might do it differently, but do it the same way. Know how you're going to go into a problem like this, what order you're going to look for things in. I think it's best to start with the low-hanging fruit. I think it's easiest to find the midpoint and the amplitude parameters to begin with. So the midpoint's just an average of your peak values. So for an example like this, the max is at 5, the min's at -1, add those two together, divide by 2, and your midline's at y equals 2. And then our amplitude is just the distance from the midline to an extreme value. And we're just worried about the magnitude at this point. So we found our D and our A parameters already. So let's take a look at our answer choices now and see if we can eliminate any bad answers. So let's check out our A's. And remember, at this point, we're just concerned with the magnitude. So can we eliminate any choices? Yep, C. Choice C is gone. Now let's check out our D values. Our D was 2. Can we eliminate any bad choices? And yes, we can eliminate B. So that problem was friendly that we could get rid of 2 bad choices pretty easily. So let's go candidate shopping. If you don't know swipe right, then Google it. So what I mean by that is this was given as a sine function. So these are some candidates that we could look at. I should have also had blue here, here, and here. Sine starting at the midline. Sine 0 is 0. So that will lead us to look at our phase shift. So we've identified some candidates, and again, I should have put blue here, here, and here as well. So we're looking at our phase shift here. So for example, A, choice A, phase is shifted 3 to the right, and that would be here. So that would not be a proper answer. And this one, it's shifted 2 to the left. Boom. So that looks like a good answer for us. And upon reflection, this looks like it's a little bit more than 2. When I first looked at it, I thought it was right on 2, but that's just for demonstration, is I thought this was right on 2, so then that would match with that phase shift. So the last consideration would be our period, and I put it last because I think that it tends to be the least likely that it's going to be determinative in the questions that I've looked at. Not that it won't be, but it's not as likely as the others. Especially the phase shift is going to come into play a lot. But first we want to find our period to find our b. So we go from negative pi over 2 to pi over 2, so that's a period of pi. And with this relationship, we find our b is 2. And let's see if these choices will tell us the answer on this hypothetical problem. And boom. If we were looking at just the b in isolation, this would be the only choice that it could be. I don't know what that means. No, I guess I do. I guess it means it's easy to make a tuna casserole. Tuna casserole's alright. You gotta have the crispy stuff on top though. With no crunch in there, it's bad. It can't be just mush. You gotta have crunch. Alright, I'm gonna ask you to do yourself a favor and take these 3 pieces of critical advice. If you see a problem where it has something about the population of blank modeled by the function, and you're looking for the maximum number of blank is blank, or occurs at time blank, or the minimum number of blank is blank, or occurs at time blank, I'm going to ask you to sketch yourself a little graph. Sketch it, sketch it, sketch it, sketch it, sketch it. And then look at the answer choices. You're going to find you have a much higher probability of getting it right if you make yourself a sketch. And then once you do that, you make a good sketch. Finding the answer choice is simple. Make the sketch. Okay, we're going to talk about FRQs. And I'm say to be on the offensive. And what I mean by that is, think about the problem like it's your enemy, and you're going to attack, and you're not going to wait for it to attack you. Do not start reading the passage straight through like it's a book. Think about what you're going to be looking for and what you're going to want to extract. If you're invading that village, you're thinking about finding the pot of gold. You're thinking about rescuing the princess. You're thinking about finding their stash of medicine or whatever. You've got your objectives. You're not just like waiting for them to come at you and attack. So again, whatever order you want to look for things, that's kind of your gig. But know in advance what you're going to look for first. And I like to look for the vertical aspects. So in this problem, with the lady rolling the wheel that we had in class, I'm looking for my vertical aspects. And they make it pretty easy in this one. So we got a max 18 inches over the ground. We've got the radius is 9 inches. So that stuff's all easy to get. Midpoint's at 9, amplitude's 9. Boom. I got off to a good start, I got some information. So I'm going to look at my B and C parameters. So I'm definitely going to try to find the period next. And they make it pretty easy in this problem to find the period. You get a full rotation. It occurs between a half second and 5 half seconds. So that's a period of 2. And I can get B from that with this relationship that we know. And B's pi. Now I can start to label my axes. They make it real easy in this problem to label the vertical. There's no confusion on that. It's simple. We want to be careful on labeling the horizontal on this problem. That's the tricky aspect of this problem. So I know that my wheel, my W on my wheel is touching the ground at certain times. So either, and I added these points E and Z, just so we have a reference on those. Either we can make J time 1/2 and Z time 5/2, or E time 1/2 and J time 5/2. And we know that it's a sine function. So we know our sine function is going to start on the midline. Now I double confirmed with a colleague. There can be only one answer. So if you make the wrong choice, like we just talked about on where to make time 1/2, you won't get the x components right. You won't get partial credit, because even though mathematically it's still a valid answer in terms of the test, there's only one right answer. So how do we figure it out? Well, think about if we made time 1/2 here and time 5/2 here, what's going to happen? Time 0 will be right here, because we had a 2-second period. I'm sorry, this right here is backwards. 2-second period, B is pi. So if we take a 2-second period, split it into quarters, then each quarter is a 1/2 second. That's time 0. Now there is a big problem with that, and that's the wrong answer. Because F is one of the points they want us to find. If they're asking for time and they give you a coordinate or a point with a label and they're asking for it, that cannot be negative in your answer. That cannot be negative. It's okay that this is negative because it's not one of the values they're asking for, but that cannot be negative. So we have to go, here is time 1/2. J is time 5/2. Which makes time 0 occur a 1/2 second before E right there. Okay, so this animation should have popped up later. I let the cat out of the bag. We need a phase shift of a second here, because these are 1/2 second increments. So we need a phase shift of 1 second to the right. So we're pi minus 1 here. And that's our answer. Now let's look at this other problem. I'm not going to go through the whole thing, but I want to point out one aspect that made a difference, and some people approach this one way or the other. First of all, you got to be careful about your period. A lot of people are still missing that they're giving you the frequency here. 5 times in a second. That means seconds in the denominator in this, and that's the inverse of what we need. They're giving you 500 vibrations per second. So the period's 1/500 seconds. And then you can solve for your b is 1000 pi. The second thing here, and again, I'm just emphasizing, write this out. I think that process can help a lot of people. Because if you write this and you have seconds in the denominator, then you know you're not talking about the period. If you're talking about a period, the time has to be in the numerator. Okay, this is where we have to read very carefully. This is where we're being systematic. They tell you how to label this graph here. They tell you. It's unmistakable the way they say it. They're telling you that the original resting point and then a positive represents above, negative, below. So the tuning fork's vibrating. So that means 0, the midline, 3 is your peak, -3 is your valley. If you labeled it 0, 3, 6, that would be wrong. And you wouldn't get those points for the y coordinates. That would be wrong. They tell you. You got to look at it really carefully. Sometimes the wording is a little bit tricky. But like we know, if they say distance, then we have to have just positive values. Here they tell you what it has to be. So mathematically, either way can be correct, but the wording of the problem is critical. That's the biggest thing that can cause you to lose quite a bit of points, is in the reading. So I want to thank you. And message me in focus if you got questions.
Loki, do you want to do math? Do you want to do math, Loki? Loki, do you want to do math? Do you want to do math? Do you want to do math? Loki, do you want to do math? Do you? Yes? Yes, you want to do math? Yes, you want to do math? Yes? Yes? Yes, you want to do math? Yes? 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 What?